Welcome to This Explainer. Today we're diving into a name that is literally synonymous with genius. I mean, when you hear Albert Einstein, you probably instantly picture the wild hair, the messy chalkboard, the absolute face of modern physics, right? But the thing is, he was so much more than just a two-dimensional icon. We're talking about a deeply complex man whose entire life, both scientific and personal, was completely defined by these massive, earth-shattering paradigm shifts.
Let's really get into this, because to truly understand the man, we actually have to go all the way back to his childhood in Munich. Picture this. Einstein is just 5 years old, sick in bed, and his father hands him a simple pocket compass. Now, most kids, they'd just see a neat little toy, but young Albert was absolutely mesmerized by these invisible magnetic forces pushing the needle around. It sparked this intense, lifelong fascination with electromagnetism. He actually looked back on this exact moment later in life, realizing that, quote, something deeply hidden had to be behind things. And wow, did that single thought set the stage for a lifetime of uncovering the universe's most fiercely guarded secrets.
But, here's a question that kind of challenges everything we think we know about genius. How on earth did a kid who was actually so slow to learn to talk that his own parents thought he had a learning disability, how did that kid end up rewriting the fundamental laws of the cosmos? It's a staggering contrast, really. His early life was actually defined by incredible struggles and massive irony, which is totally at odds with his ultimate status as history's ultimate brain.
This brings us to Section 1, the Curious Patent Clerk.
So Einstein's path was anything but a smooth, polished academic journey. Honestly, his early life was pretty much defined by failure. He was a rebellious student who absolutely despised the strict rote learning at his schools. Get this, when he applied to the Swiss Federal Polytechnic School, he actually failed the general part of the entrance exam. No way, right? And even after he finally graduated, he was passed over for teaching positions for almost 2 whole years. Eventually, he just had to settle for a job as an assistant examiner level 3 at the Swiss Patent Office in Bern. So instead of working in some prestigious university lab, he spent his days evaluating patents for things like gravel sorters and electric typewriters. But, ironically, spending all that time looking at inventions related to synchronizing clocks and transmitting signals, that might have actually been exactly what fueled the revolutionary thought experiments he was running in his head.
Because he was totally shut out of formal academia, he had to cultivate that massive intellect outside of it. So he and some friends in Bern formed a discussion group, and they mockingly called it the Olympia Academy. It was a playful jab at the scientific establishment that had rejected him, right? And alongside his first wife, fellow physics student Mileva Maric, they spent countless hours just passionately debating science, philosophy, and the very nature of reality itself.
Moving on to Section 2, 1905, the miracle year.
Well, all of that intellectual cultivation finally boiled over. In one single year, this 26-year-old patent clerk completely shattered and rebuilt the foundation of physics. It's wild. Let's look at the timeline. In March, he proposes the photoelectric effect, basically suggesting light acts as discrete packets or quanta. Then May rolls around and he explains Brownian motion, giving the world empirical evidence that atoms actually exist. June, he drops the absolute bombshell of special relativity, radically changing how we view space and time based on the constant speed of light. And if that wasn't enough, in September, he publishes the equivalence of mass and energy, giving us the most famous equation in history, E equals mc squared. And remember, he did literally all of this while still working his day job at the patent office.
Which leads right into Section 3, gravity, eclipses, and fame.
Believe it or not, Einstein wasn't finished. By 1915, he had developed the general theory of relativity. Now, to put this in perspective, up until this point, the whole world relied on Isaac Newton's view of a static universe, where gravity was just this mysterious pulling force. But Einstein, he proposed something radically different. He said gravity isn't just a simple pull, it's the actual warping and curving of the fabric of space-time itself by massive objects.
The physicist John Archibald Wheeler later summarized Einstein's incredibly complex math with this absolutely perfect quote. Space-time tells matter how to move. Matter tells space-time how to curve. Think about it like this. Imagine a heavy bowling ball resting in the middle of a trampoline. It creates a massive dip, right? And that dip totally alters how a little marble would roll across it. That, in a nutshell, is general relativity.
But, it was really just a theory until 1919. During a solar eclipse that year, astronomers, led by Arthur Eddington, actually observed stars near the sun. And because of the sun's massive gravity, the starlight visibly bent exactly the way Einstein's math predicted. It's a phenomenon called gravitational lensing. When these results were announced, headlines from the Times of London literally exploded across the globe. Newtonian ideas overthrown. Literally overnight, Einstein became the world's very first celebrity scientist.
And this bizarre, sudden mega fame was totally unprecedented for a physicist. I mean, everywhere he went, thousands of people would mob him. There's this great story from 1931 when he attended the Hollywood premiere of the movie City Lights with Charlie Chaplin. As the crowd is just going wild for both of them, Chaplin famously leans over to Einstein and says this fantastic quote, "They cheer me because they understand me, and they cheer you because no one understands you." Spot on, right?
Next is Section 4, a refugee in America.
Now, Einstein's global adoration was in stark contrast to the really dark reality brewing back home in Germany. $5,000. That was the actual bounty placed on Einstein's head by a German magazine, because he was a famously outspoken, pacifist Jewish intellectual. Einstein became a massive target when Adolf Hitler and the Nazis rose to power. The Nazi regime actually burned his books, proclaiming that Jewish intellectualism is dead. The danger he faced was immense, and it was immediate.
So he was forced to flee his homeland. In 1933, he surrendered his German passport in Belgium. For a while, he actually had to hide out in this secluded wooden cabin in the English countryside, literally guarded by men holding shotguns. Ultimately, while thousands of Jewish academics were being tragically purged from European universities, Einstein crossed the Atlantic. He finally found a permanent safe haven as a resident scholar at the Institute for Advanced Study in Princeton, New Jersey.
But once he settled in America, he definitely didn't just quietly fade into academia. He became a U.S. citizen in 1940, and his own harrowing experiences with discrimination really fuel this deeply active moral compass. He joined the NAACP to campaign for civil rights, boldly calling racism America's worst disease. And there's this incredible story where the famous black singer Marian Anderson was refused a room at a local Princeton hotel. Einstein stepped right up and personally invited her to stay at his home. It was a really powerful symbolic gesture of defiance against segregation.
Let's look at Section 5, Pacifism and the Bomb.
His time in America brought about a truly profound and honestly tragic tension in his beliefs. On one hand, you have this lifelong pacifist who literally called war a disease. But on the other hand, he's facing a terrifying practical reality, the very real fear that Hitler could develop an atomic bomb first. So, in 1939, persuaded by fellow refugee scientists, Einstein made a huge decision. He signed a letter to President Franklin D. Roosevelt, urgently warning him of the danger, and actually recommending that the U.S. begin its own nuclear weapons research. Now, it's important to note that because Einstein was a known pacifist, and frankly, a security risk in the eyes of the government, he never actually worked on the atomic bomb himself, but his letter absolutely helped spur the creation of the Manhattan Project. And suddenly, the deadly potential of his own 1905 equation, E = mc squared, the idea that a tiny amount of mass contains a massive amount of energy, was brought into devastating reality during World War II.
The weight of that reality completely haunted him. A year before he died, he made this heartbreaking confession to his friend Linus Pauling. He said, "I made one great mistake in my life when I signed the letter to President Roosevelt recommending that atom bombs be made. It is just an absolute emotional gut punch to hear the world's greatest mind express such immense regret over the unintended consequences of his influence."
Bringing us to our final section, Section 6, God does not play dice.
Moving into his final years, it's wild because the scientific rebel who once overthrew Newton found himself completely isolated from the new physics. As quantum mechanics evolved in the 1920s and 30s, it started painting a picture of a universe that was built on fundamental randomness and probability. And Einstein? He absolutely hated this. Even though his own early work helped launch quantum theory in the first place, he stubbornly refused to accept that reality was inherently unpredictable. That's where his famous quote comes from: "God does not play dice." He engaged in these massive, legendary debates with physicist Niels Bohr, just entirely unable to accept that the universe didn't have a strict, deterministic, and fundamentally sensible underlying reality.
Because of this stubbornness, his later life in Princeton was a bit of a solo journey. He spent his final years as kind of an academic outlier, just dedicating himself to this elusive, unified field theory. He was looking for a single mathematical framework that would unite all the forces of nature. And sadly, he never found it. But he did find deep solace in music. He regularly played Mozart and Bach on his violin, actually believing that Mozart's music was so pure it seemed to have just always been present in the universe.
And well, that brings us to the end of our explainer, and right back to where we started.
If Albert Einstein, the man who visualized riding on beams of light, the guy who bent space-time and unlocked the energy hiding inside matter, if he spent his last days unable to uncover a unified theory of the cosmos, it really begs a massive question. Think back to that 5-year-old boy staring at the pocket compass. If the ultimate genius couldn't uncover all the universe's secrets, what deeply hidden things are still out there, just waiting for the rest of us to find?